Light, camera, fractions.
Again.
Thank you so much.
Oh my God. I can't
All right, so up until this point, we have been solving equations, right? Equations. One side equals the other side, right? And I've given you lots of, dude, hold on. Oh, I see.
This way we can actually scoot up.
Okay. And you've learned how to deal with lots of different types of equations. Equations with decimals, right? You've learned how to deal with equations with fractions. You've learned how to deal with equations where the x is on both sides. All those things, right? Now, when you are solving inequalities, it would be just like those equation problems, only there would be a greater than sign, or a less than sign, or a greater than or equal to sign, or a less than or equal to sign. And do you guys all know those signs?
Yes.
Are you comfortable with those signs, or do you want me to just write them out?
I
Pac-Man goes for the power up.
Okay.
question about x's on both sides.
Okay,
What
guys.
if both
Guys, there's a
sides-
question on the floor. Yes.
So I have a question actually about the x's on both sides.
Right.
What would you do if both sides only had one x? And they were both positive x's?
Oh, really good question.
Yeah.
So we're going to just answer that before I move into this, right? So this is not an inequality. We're going to do. So Ben said, like, what if you had x plus 2 is equal to x minus 7, right? Something like that?
Yeah.
All right. So how would we solve this?
Magic.
Yes.
Okay, so you need to get the x's and the numbers on both sides.
Right. So let's do it. Go help me.
Okay. You could subtract 2 from each, or add 7 to each.
Well, let's get our x's together
X's.
first. Let's do our x's first.
Subtract them?
Yeah, well, let's move this one over here. So we're going to subtract x. That's really easy, right? Subtract x. So we got those crossed out. Then we have 2 is equal to negative 7. What? This is on camera? Oh! What does that mean, though? What does that mean? Andrea?
You probably made a mistake because that's.
I didn't make a mistake.
No. Oh.
I didn't make a mistake.
Or you could subtract 2 from one side and then have 0 as. Well, actually, that wouldn't solve anything.
No? Okay, Cassie. Good thinking. What? No, because it has an equal sign.
Oh,
Yes, Gideon?
Wouldn't you just subtract? Or no, wait, that wouldn't really solve for the x's.
Okay, let me ask you a question. Is there any value of x that would make this true?
No.
No. This is not true. This is actually a false equation. It is not a true equation, right? There are times when equations can't be solved and they are not true equations. This is one of them where I have the same number of x's on both sides, right? And I subtracted them. I no longer had x's, and then what was left over did not equal each other. Those are not equal. This is not equal to this.
It would
Right?
be like. It would
So
be
there
like
is no solution, right? That's what I would say. No solution. Now, what about this? What if I gave you, let me think about this for a second. What if I gave you 3x plus 2 minus x equals 2x plus 2? Oh, hi guys. You guys came in so quietly. I'm really impressed. We were about to start this lecture, and then somebody asked this brilliant question, and so we were dealing with this, realizing, oh my God, you can actually have an equation that is unsolvable, right? You can't solve it. And so then I asked, so I'm giving him one other. Now, how would we solve this? Somebody, Gideon.
You can't because there's only one actual.
Well,
digit
let's
on
try.
either
Let's
side.
get
Okay.
you're looking way too far ahead.
Okay. subtract 2 from either side. Or 2x.
Why don't we get our x's together?
Yeah, I meant 2x.
But aren't there more x's here?
Yeah.
Couldn't I combine those first? What's
You
3x
could.
minus x?
3x minus x is 2x.
Right. So let's just do that. We've got 2x plus 2, right, is equal to 2x plus 2. Oh, that's interesting. Okay, let's keep going. Now what did you do, Gideon? I don't like my x's on both sides.
So you subtract x. You subtract 2x from either side.
All right, yeah, we'll get rid of this one because I don't want that one there. Get rid of that 2x. There we go. So then those cross out. Then we have 2 is equal to, wait. 2 is equal to 2. That's true! Oh my gosh! So what does that mean?
Means that the equation equals.
It's a true equation. It's a true equation.
Is there any value of x that would make this true? Is there any value of x that would make this true? Yes. Gideon.
Oh, 2. Yeah, if x equaled 2, then it would.
If x equals 2, that's true. Andrea.
If x was equal to 0.
If x is equal to 0, that's true. Mira. No, that's wrong. Oh. What if x was 1,000,000?
It's the same.
I have, think about it, I have 2 million plus 2 equals 2 million plus 2. Oh, that's true. What if it was 1 billion? 2 billion plus 2 equals 2 billion plus 2. Oh. So, all real numbers is the solution. X could be all real numbers. I have to say real because in math, as crazy as it sounds, we have unreal numbers. Right? Kind of bizarre. We have imaginary numbers. Right? These are the things that you dream about. Right? Right? Okay. So anyways, that was a great question.
How would you make an imaginary
Ben.
number?
An imaginary number? Do you really want to see one?
Oh wait, x or y, sure.
What's this? What is this? The square root of 4?
2.
2. What's this? The square root of negative 4?
2.
Negative
Negative 2.
Ah, let's try that. Negative 2 times negative 2 is
2.
positive 4.
4.
Uh-oh. Okay, so it must be positive 2. 2 times 2 is 4. Oh, no, negative 2. Negative 2 times negative 2 is positive 4. Shoot. Right? This is on video. You guys are making me look bad. That's an imaginary number. It's actually doesn't exist in real life, right? So we have to call them imaginary numbers, but in math we actually use them. Believe it or not, crazy. We are crazy, right? Mathematicians. Okay, so let's move on. Now we'll get to the real thing. The real part of the lecture is solving inequalities, right? Thank you guys.
You don't do that with business deals, do you? You don't like shout.
What?
You don't shout with business deals, do you? We could have 3 times the deals. What?
Okay.
I want 4 times the deal.
I was waiting. When I started shouting, I realized all this stuff came out of my mouth. I was waiting for somebody to say it, don't spray it.
I was wanting to
Say it, don't spray it.
Yeah. Okay.
Say it, Gary.
Solving
Spray it.
inequalities.
Can't believe
So
you
here we go.
spray it.
I respect you too much for that, Gary.
How
Okay.
dare you spray, Gary? I can't believe you. Say it, don't spray it. There, I shouted
Okay.
for you.
So all right, inequalities. Solving inequalities. So let's just look at some of the rules. I got to see what time it is. Okay, we're fine. So what is this sign? Less than, right? That's less than. I just want to be sure you guys are all together. And what is this?
That's greater than or equal to.
Right? And then, so you're reading from left to right, right? Usually. Not always. Not always. But usually you're going to read from left to right. Just like this. So the tiny little point is first. So that is less than the big, huge opening, right? Right? And so, and then this would be greater than. That's called the greater than sign. Greater than. And with the line underneath it, it would be greater than or equal to, right? So, so now let's start seeing how we solve equations with these. I mean, solve inequalities with these. It's almost identical to solving an equation. Almost. Most of the time, you can solve them exactly like you do with equations, but not always. So we got to look at that. All right. So let's try one. Let's just say 2x plus 4 is greater than 10. Okay? So write that down in your notes. This is our first example. And I'm going to just do the same thing. I want to get my x's isolated, all on one side, right? All by themselves. So I'm going to get rid of the 4. So I'm going to subtract 4. And I'm going to subtract 4.
Gary?
Yes, go ahead.
Is the sign in a way an equal sign, or is it just kind of telling if it's telling the truth and lying?
It's really more like an example of when you'd use inequalities. We actually use them a lot, and we just don't realize it. We don't usually write them, you know, but we say them a lot. For example, how old do you have to be to drive in the state?
6.
Actually, technically, you can get a driver's license at 15, is my understanding. 15 and a half, I think, right?
I'm excited.
You can get your permit at 15.
I'll wait about 2 more years.
Okay, so it gets a little complicated, but we'll just say you can start driving legally when you're 15, right? So how would I write that? How old would you have to be to drive? X would be the age that's required.
X is greater than or equal to 15.
Okay, and I think it's 15.5, but I could be wrong. 15.5. So that would, so if I was 12, could I drive?
No.
If I was 16.23, could I drive?
Yes.
Yes.
If I was 19.7, could I drive?
Yes.
If I was 28, could I drive?
Yes.
If I was 241, could I drive?
Yes.
Stupid, right? It'd be stupid, but stupid, right? But I could do it, right?
You'll be like,
Going as fast as I can. My
Right.
leg will move this far.
The older folks
you
actually
just have to
sometimes
put your
drive
leg
faster
on.
than the younger people, right?
reckless.
All right.
This is as slow as I can go.
So shh, guys, let's come back. So we have this, right? So I'm going to just do it just like it was an equal sign. So, but Ben, I just want to say one more thing. This means whatever's on this side, when you add it all together, it's going to be bigger than what's on this side,
Okay.
right? And so you're going to start to see, because we're going to get it down to x is bigger than something. That's what we're wanting to do. And then we know how to deal with that, right? So so we got 2x is greater than 6, right? But I don't want to know what 2x is. I want to know what x is, right? So I'm going to divide by 2, divide by 2. So this is really easy, right? You guys know this backwards and forwards, right? So that was easy. Now how would I graph that? There's only one variable. You agree with me?
Yeah.
There's only one variable. So technically I only need one dimension. I only need one line. I don't need a coordinate plane with x's and y's. I could graph that on a coordinate plane. It looks a little different than if I graphed it on one line. So since it's just one variable, I'm just going to go like this. If this is 0, this is 3, x is greater than, does it equal this number?
Oh, so now we're doing more than.
It's going to be an open circle. Does that make sense? Open circle means it does not include 3, but it starts at 3.
Okay.
And it's greater than, so you do this big sort of solid arrow going in that direction.
What?
Okay? Now, ironically, look at this. As long as you have your x on the left side, look at the arrow. This is facing the arrow. It's the same direction. Does that make sense? Hi, you guys. Does that make sense? Right? Yes.
I'm just wondering, when you have like a negative x,
Mm-hmm.
would the sign like switch?
Yes. in the solving process. And we're going to get there. You'll see what I mean. Great question. It's a really good question. So does that make sense? Do you guys all get that?
Yeah.
That's really pretty easy, right?
Yeah.
Pretty straightforward. There's nothing new there, right?
We're gonna have that on our homework.
Yes.
So the timeline.
Yes. And so I'll just have you use just a regular straight line for that right now, because eventually we're going to do the coordinate plane. You know, if you're going to do that, it would look a little different. But all right. So that was example number 1. So far, same thing as solving equations, right? No difference, right? We could even do a hard one, right? Let's do a hard one, right? Let's do I don't know. Let's say 2/5 x plus 1/5 is less than or equal to 7. Ooh, that looks terrible, right? Looks like a nightmare. But it's not that big a deal. What would I multiply everything by? 5, right? If I multiply this times 5, the 5's cross out. If I multiply this times 5, the 5's cross out. If I multiply this times 5, I get a number. So 2x.
I get a number.
2x plus 1 is less than or equal to 35, right? And then I'm just going to subtract 1. No problem. It's just like solving with an equation, right? With an equal sign, right? I've got 2x is less than or equal to 34. Now what?
Ooh,
Yes,
I know.
Ben?
You would have to divide 2x by 2.
Right?
And then divide the other side by 2.
Right?
And
then
you should get 17.
Yes, beautiful. So there we go. Again, if I was going to graph this, do I have to go, if this is 0, I do have to go 0, and then 1, 2, 3, 4. No, I don't have to do that. Don't worry about that.
Just be
Keep
simple.
it simple. Keep it simple, silly.
Gee.
I learned a different word, but that's okay. But anyway, this is 17, right? It's to the right of 0, right? I don't care how many, like, right? I just put 0 here, 17 here. X is less than or equal to. It's got to be a closed solid dot, right? And it's going to go this way, right? That doesn't look like, whatever. You got the idea. It's going that way. It's less than 17 or equal equal to, right?
Okay, fine.
So the solid dot means it equals. The open dot means it does not equal, but it starts there, right? Everybody's with me, right? Makes sense. Fist to 5. Yes.
Why do the tables get gotta move around? Because I can't see.
Why do the tables get what?
Because I didn't used to be directly behind Andrea.
Oh. Because I have no idea.
It's because of the kids in Han. They keep like moving.
Would it help if we just move this table this way a little bit?
Yeah.
Okay, everybody move 1 foot. How's that? Is that good? All right. Okay.
Why do I have a body?
All right. So now we're gonna try.
Wait, let me see.
Now we're gonna try Now we're gonna try another problem. Let's say I had negative 5x plus 10 is less than, I don't know, 25. That's fine. So here's our next one. Negative 5x plus 10 is less than 25. Okay? So we're going to solve it just like an equation. Here we go. We're going to subtract 10, right? You guys with me?
Yeah.
Subtract 10. I've got negative 5x is less than 25. I mean, excuse me. What am I doing? 15. Thank you. Negative 5x is less than 15. Now what do I do?
You have to divide negative 5.
Uh-oh.
Both sides.
You have to switch.
Uh-oh. This is where the problem comes in. This is where the difference is between solving an equation and solving an inequality. And this is the rule. And this marker is starting to get fade, so I'm going to try something with a different color. I hope it works on there. But
What's wrong with the negative number?
there's nothing wrong with it. It's just that something has to happen. So write this down in your notes. If you multiply or divide both sides by a negative number, you must flip the inequality sign. And I'll prove it to you in a minute, but inequality sign. Okay? So if it says less than, it'll have to then suddenly be greater than. If you multiply or divide by a negative number. So the key is you have to be very alert. You have to be very alert when you're doing these, because it's so easy to just kind of skim through it because you know how to solve these so quickly and so easily. It's a piece of cake for an equation, right? So you got to be always asking yourself, am I multiplying or dividing by a negative number? Now, I can subtract. Subtracting doesn't affect it at all. It's only when I multiply or divide by a negative number. Now, would you agree with me I'm going to divide by negative 5?
Yeah.
Okay, negative 5, divide by negative 5. So now suddenly the negatives cross out, the 5s cross out. I've got x. This now is going to have to flip the other way, is greater than negative 3, right?
Mm-hmm.
Now, I'm going to prove it to you. Did you write this? Did everybody write this? Can I erase this?
Yeah.
So I have space? Yes?
Yeah, like he didn't want it.
Can you-
Yeah, just erase it.
I can erase it? Okay. All right, so let me just show you. Let's go to here for a second, right? I'm going to go back to there. Well, I'll just start right here. That's fine. So we've got negative 5x is less than 15. Now, remember I said it's okay to add or subtract? And that does not change the sign, right? So let's just add 5x to the other side. And then let's subtract 15 over to this side. So then suddenly, you see what I'm doing? Right? So I'm going to add 5x. Add 5x. So that gives me what's here.
Wait, are we doing new ones?
What?
No, we're doing the same one.
I'm doing this. I'm taking this problem here. I'm proving to you why you have to flip the sign. That's all I'm doing.
Well, also it would make no sense if negative 3 is greater than x is negative 3. What is it actually?
Well, you could have x be less than negative 3, right? So, but here, let me just show you. You add 5x to both sides. So suddenly I have 0 is less than 15 plus 5x, right? And then I'm going to subtract 15 from both sides, because adding and subtracting does not affect this inequality sign. So suddenly I have negative 15 is less than 5x, right? Now I'm going to divide by 5. Divide by 5. I got to squat. Oh. Okay, negative 3 is less than x, right? Now, look at this. The way you would read this, even though it's negative 3 is less than x, the way I read it is I read it as x. I read it from right to left, because I always like to read my x first, right? I read it as x is bigger than, greater than. See, the mouth is facing the x. The big part is facing the x. X is greater than negative 3. X is greater than negative 3. Same thing. Now, if I had to do this method, look how long it took me to go from here to here. Look how long it took me to go from here to here. This was shortcut, right? So algebra is about shortcuts. Does that make sense?
Yeah.
So since it's about shortcuts, what time is it? Okay, we're okay. Since it's about shortcuts, I'd rather do the shortcut and memorize that this has to flip when I multiply or divide by a negative number, both sides. Does that make sense?
Yeah.
But it has to be both sides. I mean, if a problem already has, multiply this times a negative on this side, that doesn't change the sign. It's just got, if I'm choosing to multiply both sides by a negative number, or divide both sides by a negative number, then the sign flips. Okay? So what about, let me just think for this. Let's try another one. Let's see, how about we do something like this? That was a division, right? We divided both sides by 5, negative number, yes.
What if, so you have like negative 5x is greater than negative 15. What if they're both negative? Do you still have to flip?
Yeah, because you're dividing both sides by a negative number, right? That's the issue. It's not whether one's positive, one's negative. It's whether I'm dividing both sides by a negative.
Well, you
or
know how you were doing it like the other way, like the longer way?
Yeah.
You were dividing those by a negative number too, so when you
No, I wasn't. I was subtracting them, or I was adding them to the other side and then subtracting, and then it was positive, and I divided by a positive number.
No, because you subtracted 15 and then.
It was negative 5x, right? It was negative 5x is, I don't know, was it greater than or less than? It was less than, I think. What was it? 15. And so I added 5x, right, to both sides,
Oh,
right? See what I'm saying?
So
And I had
only if the
positive
x is
5, and then I divided by 5.
It's only if the x is.
Right. If the number in front of the x is negative, then you have to divide it by a negative, right? Both sides by negative. So that's the shortcut, and that helps. You know, I like shortcuts, so it's worth it to me to memorize that little trick to flip that sign, right? Now, what if I had this? Let me think for a second. What if I had negative 2/5 x is greater than 7? I don't care, doesn't matter. Negative 2/5 x is greater than 7. I don't want to know what negative 2/5 x is. I want to know what 1x is, right?
So you multiply by 5.
I can. There's two ways I could do it. I could either just multiply by 5 and then deal with it from there, right? So let's try both our ways, right? Well, let's write them both up here. I'm going to write it again here. Negative 2/5 x is greater than 7. So who said that? Was that Ben? Okay. So Ben said multiply everything times 5. So I'll multiply this times 5. Those 5's cross out. Multiply this times 5. Then suddenly I've got negative 2x is greater than 35. Divide by negative 2. Divide by negative 2. And then I've got x is less than, right? Sign flips. Negative, what is that?
Something.
My brain. 17.5, right?
Yeah.
Something like that?
Yes.
Okay, so over here, the other way I could do it is I could multiply by the reciprocal, right? I could multiply both sides by negative 5 halves, right? Right? And then the 5's cross out. The negatives become positive. The 2's cross out. What do I do? Times negative 5 halves, right?
Yeah,
Okay. So what does this say? That gives me x. Now I multiplied by a negative, right? Is now less than 7 times negative 5 is negative 35, right?
Yeah.
Because when it's a whole number times a fraction, the whole number multiplies what? The numerator or denominator? Are you solid on that?
Numerator, because it was 7 over 1.
Right. So if it's just a whole number, it always multiplies. You get that, Gideon?
Yep.
Whole number always multiplies times the numerator. So 7 times negative 5 is negative 35. So negative 35 over 2, which actually is negative 17.5. So x is less than negative 17.5. Right? Either way. If you're more comfortable with reciprocals, fine. Or personally, I just find this is so simple. Multiplying everything by the denominator. I use that more often myself. You know, it's just pretty simple.
Thank
So,
you, Gary.
so this got moved. Shoot. Anyways, I'm not sure what was on there, but Anyways, that's it. And I will have to make the homework and give it to you later, okay?
Okay.
I
Later in
apologize.
the day.
Alright.
And it's because you guys just dazzle me.
Because he didn't know.
You dazzle me. You're such good mathematicians.